Okay, so let's look at functions. First of all, a function is just like the program main, except main is a special name which the compiler uses to know where in memory to begin executing. Functions typically have a specific function which they're able to perform. There are some interesting things about functions that we need to know, so let's take a look here. First of all, there are three parts to any function. One is the prototype, which is generally at the top of the file that you're working on. Notice that there is a semicolon after the function name and parentheses. Second, there's the actual function definition, which usually follows main. Notice that looks exactly like the prototype, except there's no semicolon here. You can also avoid using a prototype by putting the actual function at the very beginning of the file, but normally that's not done. Now inside of main, which is where we call functions, is the third area here, where for example we might have w is equal to a function of x, y, and the address of z. Notice that in each of these cases there are three parameters that are passed on to the function. This first parameter is an input, so it's just a value, in this case the value of x. The second parameter here is a double, which is also an input. In this case this would be the value of y. The third one is a pointer, in this case an integer pointer. So for that one we need to send an address. So for that we send the address of z. Now the order of these parameters are important. They need to be the same in all three of these statements. The number is important. There need to be, in this case, three of them in each case. And the types must match. So if this is an int, then that's an int, then x must be an int. This is a double, that's a double, y must be a double. This is an integer pointer, then here z must be an integer. Okay, so remember how these functions work. The inputs are just values, so this value is sent to the function and it can do whatever it wants with that value. This value is sent to the function, it can do whatever it wants. Here is an address, so we're sending the address of z, which is where we want to put the information that we finally compute here. Also, this particular function has been defined as an int, so it can have a return statement with an int value, and at the end of the execution of this function that integer value is under this identifier as function, so in this case it will be placed into this other integer w. Now if the argument is an array, as is shown here for function b, in the prototype we say int a with these two brackets and nothing inside. The actual definition looks the same, except again no semicolon here, and when we call it from the main program we're going to call it with just an array name. So this is assuming that this array C has been defined as an integer array. Remember, in this case what the system actually does is to send the address of the 0th element of this array C to the function. So what's coming in here is actually an address or a pointer, so the address of the beginning of that array. So now let's take a look at this function where we find the circumference and the area of a circle. So here we have our include stdio, define pi as a constant. Here's the prototype for the function that we're going to use to do this calculation. It's called circle, has no return value. The first parameter is a r float, which is going to be the radius. The next is the area of the circle. Here it's a float, but notice that it's a pointer, p underscore a, and then finally the circumference, which is also a float, and again a pointer with star p underscore c. Now we go to int main void, here with return 0. Here we define a float called r, A, which is going to be the area, equal to 0, C equal to 0, which is where we're going to store the circumference. We say enter the radius of a circle, we read it into R. We then call circle. This is the call statement where R is the radius, so that lines up with this. The address of A, so this variable is now going to be coming into circle, where the pointer to A is right here. And finally the address of C, so this pointer is going to be pointing to C back in the main program. Okay, then we print the answer and return. If we go down and look at the actual function, again, void circle float R, float star P underscore A, float star P underscore C. That's exactly the same as this, except that there's no semicolon down here. And now what we're saying is this: follow the pointer, this one right here, back to the variable in the memory. And when we do that, that's going to be A. Do this calculation, pi r squared, and put that into A. Now take 2 pi r, follow the pointer, star PC, that's this one. It's going to go back to the call, remember was the address of C. So now C is going to contain 2 pi r, which now when we come down to the print, where we print A and C, we'll be able to print those two answers. So again, what this shows us is that we'll call this function with a value here in R, but an address here, that's the address of A, and an address here, that's the address of C. So when this is done, it's put into the address of A. When this is calculated, it's put into the address of C.